Hello, good evening, everyone. I'm Isaac Ajawa. I want to give us way to analyzing one way ANOVA using Python. So I'll go there now to show us the way to read. Now, assuming you have your Python here, this is an example I want to give unto us, and it's quite easy. So there are ways you can do that of two ways, but I'm starting with one way. What does even one way mean? One way is having one factor. Two way is having two factor. When we have many factors, we see factorial experiments. Whether we are very versatile in statistics or not is not the just interpretation. The way you do it in Excel is different from the way you are going to do it in ANOVA, in Python. So all these libraries are very needed. Pandas, Skippy, start models, the formula, Seaborns. These last two are for chart plotting. This third and the second, third, and the fourth one, they are for statistical analysis. So once you have installed them, that is when you can make use of them. So here is an example of data set of for analysis of variance. If you look at this very well, this is we have three columns: group, which contain four levels: group 1, group 2, group 3, group 4. Then we have the layout, that's the second factor. You can see these two, they are factors because they are the one contributing to time spent. If you want to interpret this in regression perspective, we say time spent depend on layout and group. We can say the time spent will be dependent variable, while group and layout will be independent variable. But this is ANOVA. In ANOVA, what do? In ANOVA, we try to test whether the means across the group are equal. So the null hypothesis, that's H naught, will be there's no difference in the means across the three groups. So we reject the null hypothesis if the level of significance, if the p-value is less than level of significance. So now I want to show this. The DF is data frame. The keyword here is data frame. As you could capital D, capital F. So if I click on this now, I enter it, give us this. Already is here. And you can see if I remove this, see what will happen. It has scattered it, but what this /n is doing is to create a space between the subheading of the table and the table itself. So you can see it here. I want to include it. I want to include it here, and that is what we have here. If I enter this now, you can see. So now the values can, if you look at the groups, the four groups, they appear three times. That's why you have these three. Then the second column contains the layout. We're talking about the layout and the group. So here we have these values. This is how the data look like. So we want to see effect of group and layout on time spent. This layout, this website layout, this is the time spent, this is the group. So you can see now we want to perform the one way ANOVA. The model is this square. the time square, the time spent is this the response variable, otherwise known as dependent variable. This layout, this is the one we are dealing with. Look at it. If I pick group, I'm going to put group here. If I want it to be two-way, I'm going to add another one here inside. I say plus group, and data is df. Then dot fit will give us the fitted model, the ANOVA table here. So this is it. I want to print the ANOVA table. Just type print what you have done here. Then you enter this. Then if I just remove this, can clear it and enter this. You don't have any model here. Put it back. So the ANOVA table is here. We look at the ANOVA table here. Reveal it. This is the ANOVA table. 0.005. This shows that layout is significant. It's a good predictor for the time spent, the website layout. So the website layout is a determinant for the time spent as somebody who is using the internet or visiting the website. Now, the model summary is this. You can see this is the model summary. Dependent variable is this, the OLS, the time we are doing it, number of observation, everything. The R square, you can see 0.96691. This shows that 69.1% of variation in time spent is explained by the model. It's also a good model, at least it's above 50%. Now here you can see the layout details are here. Then we can see the omnibus, the skewness, the kurtosis. Now, assuming we reject our each node here, of course we have rejected because this is 0.005. We are rejecting each node that says there's no difference in the means of the layout means. So, we are rejecting it because this one is less than 0.05. So because we are rejecting it, we should know which of the level here is A, B, C that's giving us the differences. We need to do that. We are going to use what we call post-hoc test. Post-hoc test using Turkish ASD. It is not Turkey alone that's giving us the results. We also have LSD, we also have Duncan. We are just choosing Turkey. So you can see the library we are using here is that of start model. You can see is here. This is what we are using here. And it's going to give us, without it, we will not be able to solve that aspect of analysis. So the time spent, this is response, these are the groups. You know, this one has groups, it has ABC. So group 1 will give us A, group 2 will be AB, see, AC. It's going to, the thing is that we want to know the mean difference. And multiple comparison of means, that's what it means. Now when you pick group 1, A and B, if you remove A from B, the mean difference is 3.5. Let's go back to the data and explain what I'm talking about. You see, these are the groups for layout. If you remove A from B, from this group 1, A, this is group A from B, in terms of mean, what's the difference? Then A here minus C, what is the difference? Those are the mean differences you're talking about. You can see. So multiple comparison, and these are the remainder. This is the main difference. Difference here is 3.5. Are you rejecting each not or not? You are rejecting true. Now if you don't understand this, these are the p-value that will lead us. 0.022, this is less than 0.05. Anytime p-value is less than 0.05, which is level of significance, we are rejecting our each not. That's why it's true. You can't see this one in SPSS, but you're going to see sign star there. But Python has gone far that it's going to give us our decision. True, you are rejecting. This place you will not reject because 0.625 is greater than 0.05. Therefore, the difference is not significant. That's what it means. Difference is significant here, it's not significant here. This one is 0.053. This one, the difference is significant. This minus 45, see, is too big. And that's why you have p value of 0.05. So here we are rejecting H not true. That's about it. Assuming you want to work, okay, I think I've done this, just repetition. So I can delete this. To delete a cell, just type dd. That's gone. Yeah. You want to visualize the result now. Like I've said, visualization in analysis is very, very important. You don't need to wait until you go and look for Power BI or some other. Python can give us very good visualization of our data, and that is what I'm using here. So you want to show what you have done by visualizing it. So plot this using box plots. You can see box plot. Seaborn is very good in that. And you can see from here straight that website layout of B is giving us the highest. You can see it. So assuming this one is not, this one is for another data. So delete this. It's for another data entirely. So as I've said, we need to visualize it. So today we are able to cover one way analysis of variance using user engagement time by website layouts. And we have seen when we compare the results, each time we have rejection of H naught. So where we have the differences, we use Turkey as one of the post hoc tests we have. So next video I'm going to show us two-way analysis of variance using the same data, because we have two factors here. So the second one can also be used together before we now go to regression. Thank you.